What's up, guys? Welcome to another episode of CCT. Today I'm going to be doing threesome for the threesome problem for the first time, and I haven't done this in a while. I'm kind of just jumping right back into coding. I've mainly been reading my book recently, but I wanted to get back into actually typing stuff out. And in order to make this more similar to an interview, I don't think I'm going to be drawing stuff out now. I want to practice just speaking through my thoughts as I do a problem like this. Okay, so I'm going to read the problem. So you're given an array of numbers and integers. Okay, are there elements such that this? Okay, so we're going to, oh, gotcha. We're going to return the three elements that sum to, are there elements A, B, C that sum to 0? Find all unique triplets, which gives the sum 0. Okay, so we're given a list of integers here, and we're going to return a list of triplets such that they sum to 0. And those triplets have to all be numbers inside this array. Okay, so then I guess the next thing to do is make sure I understand this example. So if we have this, a solution set is -1, 0, 1, -1, -1, 2. Okay, yeah. Okay, let's start with a basic brute force. So for my brute force idea, I wonder how fast I could code this. Ooh, not caps lock. Okay, so and the brute force is going to be going through every combination. So let's do for I in range num. Wait, how do you? Oh yeah, you have to do the length of nums. Yeah, I was just thinking if we could just iterate through nums, but we do actually need the index, so that for this loop, we can do from I to the length of nums. So what this is doing is, like, if our first index is starting here, our second one is starting here. We don't want them starting at the same place, which is why I probably should have I plus 1 here. Okay, that's great. And then for k in range j plus 1 all the way to the length of nums. Okay, so now that we have all of those, okay, let's have, whoa, this is all indented a tad too much. Let's have let's make the result equal that. So here we could have if I plus j plus k equals 0. Now it does need to be unique, right? Or does it not? Find all unique triplets. Interesting. So it's saying to find all unique triplets, but it's not guaranteed that all the numbers in here are unique. So I guess what that makes me want to do actually is make this a set, and then kind of just do res dot add. I forget how you put stuff in a set, but yeah, and then let's add the triplet j I j k. Oh, but wait. Not just ijk, I want the set of ijk. Okay, how do you make it? Because I want a set of them because I want -1, 0, 1 to be the same as 1, 0, -1. So let's say quick search up here. Part of me thinks it's with the brackets. Yep. I was just gonna say that. Okay, so I'm pretty sure instead it's like this. Okay, perfect. And then what I want to do is, okay, so we have, I need to turn this all into a list. Okay. Set to, this makes me think it's not the most efficient way to do that, but do you just put list around it? Okay. I'd have to iterate through every, this is just unfortunate. Yeah, I'm gonna have to do that. Okay, I don't even know how you loop through a set in Python. You see, this is why I need to do more typing stuff. How do you loop through a set? Was this looping? Iterate over a set. Oh. Okay, let's just do this. Keep it brute force this. For s in result, let's do res list gets that. Res list dot append. Let's do list of s. Okay, quick check through this and then let's see if we get this. So we initialize a set, and the reason why we're doing that is so that we don't have duplicates and we could just keep putting stuff in. The alternative would be to store it in a list and then check to make sure it's not already there. But that, if we're doing that so many times, it's better to choose a set data structure because lookup is O of 1 on average. Okay, and then, okay, we loop through all of these. The I plus 1, J plus 1, that makes sense to me. Yep, that makes sense to me. And then if they sum to 0, then you add the set, because negative 1, 0, 1, like I said before, is the same as negative 1, 1, 0, for example. But if we don't put it as a set, then the set of these sets won't recognize that it's the same. So now that it's a set of sets, the order doesn't matter. Then, since it was a set of sets, we need to turn it into a list of lists, since they insist on that. And so yeah, that's that. Let's check that out, and then we'll think of a more, oh, they have a debugger. That's pretty cool. Okay, so we have nothing in our output. There's a debugger. Does it work? Oh wow, it does maybe work. Let's see. I've never actually used this debugger. Okay, so we're at 0, 1, 2, which is like pointing at these three indices, and they actually do add to 0, so let's see what happens. I mean, what? Oh, okay. Did you guys see the problem? That was kind of stupid. So I need nums, like the actual value of them, to be that. That is a classic mistake. Yeah, and then that's what I'm gonna add here too. So nums of I, nums of j, and nums of k. We don't care about the indices, right? No. Okay. We care about the actual values. So let's do that again. Unhashable type set. A set is an unhashable type? Okay. So what that means is that, I didn't know this, is that you can't put a set inside a set because the set is not hashable. And whatever you put inside the set needs to be hashable. Interesting. Okay. That is so unfortunate. Let me look that up. Or a better question, like, why is it unhashable in Python? I just can't believe that. Why would it not be hashable? You can't have a set of lists. You can't even have a set of lists because lists aren't hashable either. Huh. Okay. You know what? Wait, no. I was gonna say we could just delete the duplicates, but that... Okay, I know what to do. Let's... So apparently lists are... I mean, I want to try that out myself, but... What I'm gonna do is I want to sort these three and just put them in increasing order. Because apparently sets are unhashable, but if we put them in the same order, like ascending order every time, then you won't have the error where you have two different sortings of these or combinations. Okay, so I'm just gonna call the sort function. I think that's how you do it. Yeah. Actually, I'm gonna just trust that guy right, because he said you are creating a set via set call, and sets needs hashable types. You can't have a set of lists because lists are unhashable. Fine. So what I'm gonna do, okay, how to sort a list and return it. I know there's a difference between, wait, is it sorted or sort? Good question. Code Academy time. Hopefully my recruiter would help me with this, but lists also are different objects. They do different things. Both are callable. Okay, this has no return value. Okay, that's not what we want. Leaves argument unchanged. Returns consisting of the same. Okay. Got it. So give me that, and then I want this. Whew, this is going to be a very cute thing. So I'm going to join these with that. So now it is a string. Yep, got it. Let's see what x is. I want to debug this, please. So I turned it into a string because lists are unhashable. So this should get in here. And then what is x? Did I not step over? Are we at an error? No. We are, okay. Okay, expected string int found. Let's break this up so we know what's going on here. So we got L, which should be the sorted list. Then this should be X should be dot join of L. Okay, now let's debug this. So L is correct, and then X should be... Is that not how you do it? Oh my god. Wait. Turn a list into a string with the join in Python. I can't believe I'm getting that wrong. Yeah. So what's the problem? Expected string instance. Oh, it needs to be strings inside there? Oh. So we need something like this. Okay, we can stop this. Yep. Okay, let's try that. Okay, great. X equals that. And I did put the comma there because, yeah, I wanted to be able to separate it. So anyway, now that we have it as a set here, and we can't just apply the list here, what we need to do is we need to do s dot strip it of its comma, because that's what we did it, and then we need to turn these back into ints. So use a little list comprehension. We're going to go through and turn it into an int for each one of these. Yeah, okay. Yeah, you could take this off. We don't need that. So we could debug there. Okay, that's what S is. So now, does it get added? Like, I can't tell if this is doing anything I want it to do. Invalid literal for int base negative. What? It can't do that? Hold up. Do list of strings gets that. I'm curious what this is, so if we could just debug that for a hot sec. Alright, this is taking longer than I thought just to get the naive solution working. Okay, so list of strings does not do what I wanted it to do. What the heck? Why is strip not working? Oh, not strip. Split. Although strip should be taking that out, so I don't know why it didn't do that. But yep, so the opposite of join is split. Great, that is what I wanted actually. So good. Nice. So now we have -1, -1, 2. Great. So I think we're good now. If we try this. Okay, yay, success. Alright, so what we had to do was I turned it into an ascending string. I made it ascending because so they're all the same order so that repeats won't come in. And I turned it into a string because apparently a list and a set are not hashable. Thus, neither of those types can be in set. But of course, a string is hashable. So I was able to concatenate the data with the comma and then split it with the comma here again. Another thing that I learned was apparently Python can't do these implicit conversions, stuff like this, and I would have sworn that that Python would have known to turn the strings here into or turn the integers into strings, but it didn't. I'm gonna submit this. I don't know if this is good. Okay, yeah. This is probably, yeah, because of time limit exceeding. So, yeah, let's get to the fun part, I guess, which is how do we optimize this? Okay, so what we're doing now is we're going through every combination here. If you guys remember from 2sum, one way we were able to find the target in O of n time complexity. Actually, wait, I should be explaining this differently. I want to do this as if I'm in an interview. Okay, so how do you improve the time complexity? Well, let's see. If we sort this, then we could do a lot of pruning as to when we could have like 2 pointers on either side kind of moving in if it's sorted. So yeah, we could do that, and that idea is from the 2sum idea. Okay, maybe that's good enough. So actually, let's do this. Nums.sort. So that's going to sort it, and instead of this idea here, we're going to have, let's call it left equals I plus 1, right equals the length of nums minus 1, and we're going to have a 2 pointers approach once it's sorted, so that we could, instead of making this part what used to be n squared, we could do it in n time by instead of by like kind of oh god, how do I explain it? If the current sum is greater, then we can be moving our right pointer down, and if our current sum is less than 0, we could be moving our left pointer to the right. It's kind of a way of, instead of iterating through everything, we can kind of narrowed down the approach by having 2 pointers on either side. So while left is less than right, strictly less than, we can't have them being the same. What we're going to do is we are going to check if, okay, kind of actually really similar. Well, that's an interesting question. So what happens if they're equal to each other? Are we done with this specific I, or let's see, if we have like, no, we're not. If we have like negative, oh wait, yeah, if we have like negative 10 here, and then maybe like negative 7, then positive 17 here or something, so we found a zero sum. It's possible that there's like a negative 6 and positive 16 here. So we would move both of them in this case. So left plus equals 1, right minus equals 1. Okay. So else if it's less than 0, oh wait, I gotta change this. It's I left, right. So if it happens to be less than 0, then that means we should increase the left one because we need a larger number. And if you increase, like by decreasing the right number, that's not helping you at all. You should increase the left number. And then else, let's just do right minus equals 1. So yeah, this is the 2-pointer idea. Let me think of how I could say it. If the sum is less right now with where your 2 pointers are, maybe like here and here, and it's less than 0, let me put it this way. Decreasing your right will only guarantee that you get a smaller number. You might eventually have to decrease the right. Like, I'm not saying by just increasing the left you're going to find a sum to 0, but at least for right now, the only way you could get to make progress closer to 0, if the sum is currently less than 0, is to move the left pointer up. Okay, and maybe now it overshoots the 0, which is fine. I mean, yeah, so then you would move your right pointer down. Okay, let's run this code. Well, shoot. That is true. Now how the heck, commas, I need commas here. Jeez. Okay, great. Let's submit this. Okay, so it seems we failed the test case when they are all equal to 0. Interesting, because when it equals 0, I am moving both inwards, so the time limit is just exceeding. Is that the only case that you don't have to keep looking. Yeah, I think that might be the only case, because if it does equal to 0, there's still possibilities for other ways to sum to 0 by moving both the left and right pointer in. However, if they both equal 0, is this? Yeah, this is an edge case here. Well, yeah, I think this is just an edge case. I think what we could do is say like I don't want to have a specific edge case here for when it equals 0, but maybe I should. So it's adding. So like, what is the problem? The problem is that all of them are summing to 0. Huh. Yeah. I don't... Okay. Let's have it actually here if... No, let's do it here. No. And let's just do it here. If nums at 0 equals nums at -1, which equals 0, then you can just I feel like, is this cheating? Because it's a time complexity thing when in this specific case, but there's no way to, well, I guess maybe I can just say while it's the same number, keep going, but I don't know. I mean, maybe that's an optimization, but I'd rather just do this. So while it equals that, then just yeah. Okay. Let's see if that's better. Wow. Okay. If nums is empty, sometimes these cases are really annoying. Then just return nothing. I guess we didn't have that case before because it wouldn't even get through here. Okay. What? Has no attribute empty? Really? Empty list Python, is that not a thing? Checking empty list. Oh wait. Isn't it just like if not something? No, submit. my god, these edge cases. Okay. If length here is less than 3, then return that. How about that? That'll solve all the cases. Great. Okay, so I'd imagine, yes, I could increase the speed by doing something like if it equals 0, just like keep something about repeated numbers, like since it is sorted. I don't know, but for now this is the idea. You loop through here and then you have left and right pointers on opposite sides that keep walking into each other. Yep, there's a lot of good things here. I'm probably gonna actually, yeah, I mean, let's look at some of the discussion. I'm actually curious how I did it a year ago and a lot faster runtime. I mean, I doubt I actually did this. I probably just looked at the solution. Oh, it was also in C++. Okay. So, sorted it, did that stuff. Okay, if A is greater than 0. Ooh, that is a good optimization. So A is like the starting we could break. That is a brilliant observation. Okay, love that. That like is so good. So, by the way, I really doubt I did this. Okay, so if I is greater than 0, okay, why would I not be greater than 0? And A equals nums I minus 1. What? Okay, this line I'm not sure what it means. If I is greater than 0 and the value of I equals the value, if the value equals it right before it, So it's kind of saying if they're the same, but is that... Okay, I love this idea. But anyway, this is like a cool initialization, but you don't have the increment stuff. This part, I don't know if I agree with. What if there's two numbers... I feel like I just feel like it's possible to have a duplicate numbers here, because this is saying just skip all the duplicate numbers at the start. It's possible to have like -1 here and then J be pointing at -1 here, and then there's definitely a solution here with K being 2 on the right side. So I don't know why I seems to be skipping through all the duplicates. Okay, but anyway, let's see how they did stuff. So vector pushback. Huh. Funny, they're not... I think the problem must have been different. Because this is definitely going to push back duplicates. Oh, and they also have this while J is less than K and B equals that, then you keep adding it. These are some interesting optimizations. They're all saying that if they equal the one before them, then just continue on. Like, I agree with these actually more. Because, yeah, it's not like... I want to see how much that increases my speed, though. Adding that line here. Yeah, these are some really clever observations. Yeah, but what each of these is saying is that while it's the same, you just keep moving. Oh my god, is this how they stop? No, is this how they make sure it's unique? Okay, yeah, that definitely cut my time complexity by a good amount. No. No, that doesn't guarantee. Okay, maybe. Anyways, I think I'll leave it at this. So, yeah, thanks for watching, guys. I want to keep trying to do interview style questions just like it is in an interview where I'm just coding and trying to describe it without a drawing board. I'll also do the drawing coding videos too. But yeah. So if you guys have any videos you want me to do, let me know in the comments, and I'll see you next time. Bye.